will officially welcome everyone to this month's edition of From the Field, the Farm Chat with Idaho Wheat. I'm Casey Chummer. I'm the Executive Director of the Idaho Wheat Commission. And based on participant feedback from our previous webinars, we have moved to a true forum format so that everyone will be able to get on their microphone, ask their questions, and have a little bit more of a discussion. The chat feature will still be functioning, so if you prefer to type in a question, I can read that at the end of the presentation as well. Today, we're very lucky to have Dr. Arash Rashed with us. He's an associate professor of ecological entomology from the University of Idaho, and he's going to talk to us today about grasshoppers, but I will mention that we have several research projects on different topics with Dr. Rashed that are ongoing, and so we are very familiar with him and appreciate all of the work that he does on behalf of wheat farmers. So without further ado, this will be about a 30-minute discussion, and go ahead, Arash.
Well, thank you, Casey, for the introduction. And thank you for the invitation. So today I was asked to talk about grasshoppers, and I'm sharing my slides now. So just a few to help me with leading into the discussion at the end. So I just like this first this photo that I saw on Google, so I thought that I would start my presentation with this. I thought it's a very nice artwork, but a lot of us actually don't like this insect because they're causing damage. But you know, I don't know about you, but as kids, I used to play with them all the time, and I found these grasshoppers fascinating, but kind of scary when they actually kick to defend themselves. Before I get into details about grasshoppers, I thought it's important to differentiate the grasshoppers and katydids, because that's a question that we get sometimes. Generally, their body outline is slightly different, but they both have those powerful legs that would assist them with jumping and moving around. And the main thing that would differentiate these two groups is their antenna. You know, well, as entomologists, we have other characteristics that we use to tell them apart, but for general public, we usually just talk about the antenna. They're shorter and thicker when it comes to grasshoppers, but they are more hair-like and long when it comes to katydids. And here in this photograph, here's the antenna of a katydid. As you can see, it's hair-like and very long. And for grasshoppers, it is much shorter. And with this definition, Mormon crickets that are probably you're familiar with their damage, especially in southern Idaho and Utah areas. Sometimes there are large populations that could cause damage to wheat crop or other crops. They also fall under the category of katydids because they have these long antennae. Now, we're going to talk about grasshoppers here primarily because they have been an issue in multiple locations across Idaho. They're usually a sporadic pest, both in terms of locations and when it comes to year. So they're not always there, and there are some triggers that would promote their populations and makes them to become damaging to crops. And I will talk about some of those here and in next slides. When I say sporadic, it means they're also highly mobile. So if you see them one day in one location, it doesn't mean that the population is there, and it doesn't mean the next day, and it doesn't mean that the population would not appear somewhere else in the following day. So they're highly mobile population as well. And as I said, most of the times numbers are in check, but a lot of times due to environmental factors, they could become pestiferous in our region. There are many species of grasshoppers that we have. I found a box in our museum, so I snapped this photo of some of the examples that we may come across. But the four that I've seen more in the fields. I put here the differential grasshoppers, red-legged grasshoppers, migratory grasshoppers, and two striped grasshoppers. And it's just basically the names that they get is based on morphological traits that they have. Usually, sometimes you can see variation in color, so we need to keep that in mind too. These grasshoppers vary vary in their in the type of food that they utilize, but most of them, the ones that I want to be talking about here, they usually talk about a wide range of crops and including grasses and broadleaves. A little bit about their life cycle. They usually lay their eggs in late summer and fall and in upper 2 inches of soil. In this photograph on the right bottom side of the screen, you can see a grasshopper that penetrated the soil. As you can see, extended their abdomens, their telescopic abdomens into the soil, and she'll be laying eggs. Here, the number of eggs, I think I have it here. Yeah, it could be between 20 to 100 total, but they usually leave them in egg sacs. And here's an example here. You could have multiple, usually even up to 12, 20 eggs in each of these egg sacs. And here, of course, you see it's way more. It just varies based on the species. But in average, we are expecting a female would lay 100 individual eggs in total in these sacs that they make in the ground. Excuse me. Their life cycle is incomplete, which means that they don't go through those the pupal stage per se. So when the female lays the eggs, they would hatch, and the individual that comes out of those eggs would exactly look like their adults, with the exception that they're smaller in size and they don't have wings. So what happens is that as they molt, they gradually feed, they molt, and they develop those little wings, and they start becoming larger and larger in size. The highly mobile stage is adult stage, because that's the only stage that they actually have fully developed wings. And during these stages, they could be more, during the nymphal stage, we call them, they could be less mobile. They walk around, hop around, and they're usually concentrated in the spots that they move to, and they're less mobile, as I mentioned. The female, when they oviposit, they like to oviposit, especially these species that I'm going to be that I'm talking about in Idaho. They like undisturbed hard soil. You could find those on the roadsides, pastures, outside edges of the fields when you have natural vegetation. And when the eggs hatch, these little nymphs continue feeding in those areas, primarily focused on those areas. And they go through 5 or 6 of molting or instars until they make it to their full adult stage, and they can move away. When they get to the adult stage, they can live for 1 to 3 months after that and continue feeding. And sometimes they become very damaging towards the end of the season. A lot of cases that we see in Idaho, late summer, early fall, especially when we have warmer falls, extended late summers, that's when they become really damaging. And here is just, I found this image on Google. It was very nice, so I thought of using it. Of course, they're pretty beat up, as you can see in this photo, but that's generally how these are the eggs, the first nymphal stage, and then they molt until they become adults. And this is an example of the damage that they can actually cause. So we're going to be talking about generation time and damage risk. These are all approximate when I give the months here. Of course, we know that the environmental condition and climate is changing constantly, so it all depends. It's just what most usually we expect to see these timelines. The egg hatch time varies among those species that I brought up. We had 2 striped grasshopper. I use GH for grasshopper to make it less texty. So they usually come out in mid-May to late May. We have migratory grasshoppers that come out usually late May to early June, and red-legged grasshoppers throughout June. We expect to see their emergence from the eggs. When you have good conditions, we may have early hatching. How early? It's usually as early as a month, which could be a problem. So basically, we would have their presence in the field for longer periods when they hatch early, and then adults will stay in the environment usually for longer periods, and then they can cause damage later into the summer as well. The crops that are susceptible, they're usually very early seeded crops. Some growers have the tendency to do that. I understand there are reasons for it, especially soil moisture would be suitable at the areas. So growers decide to go in and seed early, or if they're grazing, they just want to get longer period of grazing out of their crop, which is not common in our state. But that early seeding would make the crop vulnerable to a lot of pest conditions, including grasshoppers, including barley yellow virus, as you heard about, and Haitian fly damage, which we usually concentrate in northern Idaho, but we just recently received a report from southern Idaho again last week, or a couple of weeks. It was last week. So these are things that we need to keep in mind, that early seeding is not necessarily beneficial. And a lot of times we think if you use seed treatment, it's going to protect us from these conditions, but that's not the case. And I'm going to be talking about that cereal school later. So if you have any questions about that, you could ask me there as well. For other pests, I mean. But the question that we get most of the time is that what is promoting these outbreaks? Why these grasshoppers not there, but they're there some years? We have some general explanations, which variation in climate is one reason that is being proposed, which is actually right, and we're going to focus on that a little bit more in this next slide. So in order to understand what could promote their conditions or their outbreaks, we need to know what they like and what they do not like, and so that would actually give us a better ability to predict what may be happening, and then we can prepare for that a little better. They do not like extended cool and wet weather early in the season, early in the spring. So egg is the only stage that is the stage that these grasshoppers, or most of these species of grasshoppers, overwinter in Idaho. So they lay their eggs, females lay their eggs in the soil, and they stay like that throughout the winter. Now, if you have a warm spring, they would emerge and start causing damage. What they don't like is when the spring is extended, it's late, you get cold weather, these eggs stay in the soil for a long time, you get extended rain, wet weather, it would promote damage, it would cause eggs to die in the soil. So these are all not good for the grasshopper. Actually, an extended diseases, especially these eggs and the nymphs that will come out of these eggs are extremely susceptible to diseases that could spread rapidly in the population. So those wet conditions and extended cool will promote that as well. What these grasshoppers really enjoy is hot, warm weather, especially in the spring. The eggs would hatch. At that time, if you get some quick rain for a day or two, it would help the green to come up. It would help grasses, and that would be basically the ideal condition for them. So the short period of rain, a lot of rain, is not going to impact grasshoppers, actually benefiting them. What they don't like is extended wet conditions that would be detrimental to their populations. So you get these early hatch, you have plenty of food available, so they're going to start feeding. Other things that they like, as I mentioned, undisturbed soil. If you have a no-till, a lot of systems in our state supports that in dry land, because we don't want to till, we want to preserve water, and that actually is supporting grasshopper populations. But again, grasshoppers, they have the tendency to be on the edges of the field and also outside of the field as well. That's where they really like to lay their eggs. If you have an area that is not dense, if you're outside of your field, you have these grasses, you have combination of grasses, let's say broadleaf, natural vegetation, they don't like dense canopies. They like those plants to be there, but they don't want it to be dense. So one way to discourage them from laying their eggs is to make sure that you have enough plants on those places that these grasshoppers may go and utilize. They actually like sun because they thermoregulating sun. I was looking at some old literature actually just before this talk, and I came across this bulletin that they were talking about It's 1957. I found in one of these old boxes in my predecessor's cabinet, and it's actually written very in a very casual way, and I like reading these old documents. And they were saying, well, in large populations, when we have these extreme outbreaks of grasshoppers, which luckily we haven't seen here lately. These grasshoppers could cover the ground, and you walk basically into a ground that is just it's the floor mat is grasshoppers. So he was suggesting that if you, for fun, he could just go there and gradually, slowly approach these groups of grasshoppers, so his shade would cover their populations that are laying down on the floor, and these grasshoppers would suddenly start moving to outline of that shade, and it was just something fun for him to do. That's how much they like sun, and if you make a dense canopy, they're not going to like that, at least to stay there. Now, when we have a dry season, which has been the situation last year and the year before that, we have these plants that are around the field edge or in rangelands that would dry really quick. They're usually not managed, and they respond to stress pretty quick. And that's what these grasshoppers don't like. They start taking off and they get into fields and start feeding. So that's one of the things that could promote their movement into fields, and they could feed on wheat head if you're planting wheat, barley head if you're planting barley, and that's going to be really damaging in large populations. And of course, again, as I said, if you have early seeded crop, these populations at those dry times towards the end of the season, they move into early planted crops, and they would basically get rid of the seedlings, the fresh seedlings that is available there. And when you have these extended falls, I also put as a note, you have extended warmer falls or extended late summers into fall, then it would give these grasshoppers more time to lay eggs. So more eggs per individual is going to be laid during those extended warm weather towards the end of the season, which would translate into higher populations of grasshopper in the subsequent season. And then imagine if the subsequent season, though those egg hatching is going to be, we have suitable conditions for egg hatching, that's going to be a disaster. So these are all basically factors that would lead to an outbreak, could lead to an outbreak eventually. There was something else that I wanted to talk about. I think I missed in one of my slides, or maybe I'm missing actually one slide, and I do not know why. Anyway, if I remember that, I'll mention it was related to outbreaks. So I talked about some of these factors that influence the outbreak of grasshoppers, and we are aware of. So we use that information. I just talked about temperature. I talked about moisture because they are most important in predicting these outbreaks, but there are other factors too. For example, these different grasshopper species, they prefer different types of plants, especially when they're younger and natural vegetation. So if there are conditions that are impacting population of some type of food for these grasshoppers more than the other, it will impact their survival. And so it's not usually that simple to predict where the outbreaks are going to be. However, there is a relatively good knowledge of these factors that could influence the populations. And we have this predictive models that USDA uses to predict outbreaks of these grasshoppers every year. And it's always available online. And I put a QR code here if you basically, hopefully it works. I think I checked it. If you go there, it will take you to that page and you can see this historical data. So they get the data from the year before and to predict what's going to happen in the subsequent year. So I think this was the one that I chose for, it says 2022 rangeland data. That's what they're expecting. And you could actually go to that data set, and this prediction is based on what they saw in 2021. And you could look at these, use this hot heat map and see where the hot locations are, what locations are going to be in higher risk versus the other. So we have that data, and we use that, and I shouldn't say we, researchers that work on grasshoppers use that data in order to be able to predict where the hottest spots may be. We have 17 Western states that are being monitored constantly for grasshoppers, and Idaho is one of them. I'm looking at this map, and I can perhaps say maybe this their sampling or their data is concentrated in certain areas as well. So we may want to keep that in mind too. But this is a good resource. I found it very helpful. One other thing that I wanted to talk about actually on one of the previous slides when I was talking about favorable condition is that, we talked about the number of eggs. We talked about, I talked about the springs that are hot, warmer, and we get suddenly one quick rain and then stops. That really promotes, it's good for grasshoppers because it would assure that the food is there, and also at the same time, the rain is not too much rain or too much wet weather that would cause them to die. When these eggs, they hatch, those nymphs are very susceptible to these conditions. So they can die really easily. About 40% of these eggs would actually survive and make it to the next stage. So any condition that could promote the additional survival of these nymphs are very important. And when you get those hot weathers and food available, that nymph can quickly feed. And when they feed, they start feeding and their digestive system starts to work, then there's a higher chance for them to survive. So that little period that they're very susceptible, they just hatch, they're trying to find food. If they don't find it quick, they're going to die. And that's how important those having green available to them is at earliest stages. So what about their damage? When numbers get really high, they become damaging. And as I said, field edges are highly susceptible. You go to outside of the field, they're flying around or hopping around. If you go inside the field, if you feed, usually they're large populations. But expectation is that as you get inside the field, you'll have less and less grasshoppers, hopefully. And that's what we expect to see normally. Question is that how many of them we would have, we should have to be concerned about. It all depends on different factors. The environmental condition that year is something for you to judge. How much production, what would be the gain from that year for you, and then how old is your field is a big factor. If your field is very young, if you have a seedling stage field that is just planted, if you have 3 grasshoppers per square yard, means that you would need management. You have to be careful. These things can feed really fast. I was looking at reading at some of these articles about grasshoppers, and they were talking about numbers. So they said, 15. If you have 15 grasshoppers per square yard, is a large population. And that would basically translate into 100 pounds of grasshoppers for an acre. And 100 pound of grasshoppers is almost like the size of a sheep, right? So they can just feed and graze on those things. And the unique thing about these grasshoppers, or the difference between feeding by grasshopper and an animal that is grazing in a range, is that they have a small mouth parts, and they snap the plant right at the base. They basically get rid of it. When you're grazing, you're grazing with large animal. So the way that they feed, you still have plant to recover. So sometimes feeding by these grasshoppers would not even leave that chance. So this makes a big difference. And of course, damage to heads is critical. If you have late season damage and you haven't harvested the crop, and the seed are there for these grasshoppers to feed on, that would be disastrous as well. So there are control measures that can be taken for these grasshoppers. I know that we would like to see them. We usually recommend integrated pest management for grasshoppers and these kind of sporadic pests. Management in rangelands are done by the government, by the state in the years that we have outbreaks. But Regardless, you need to inspect vegetation around the fields at least 10 days before planting, because remember, the seedlings are very susceptible to these grasshoppers. So start monitoring 10 days before you're planting. Look at the natural vegetation around the fields, those roadsides, places that or rangeland that you have right next to your field, that these grasshoppers may move into the field. If you early seed at that time, that's not good. I'm talking about fall planting. In the spring, early seeding is good because by the time grasshoppers start moving, your plants are larger and they can withstand more damage by these grasshoppers. So these are the things that you have to pay attention to if you have a fall crop versus a spring crop. So early seed in the spring is good, late fall is good, and we have to keep that in mind. Crop rotation, not just for this grasshoppers, for other grasshopper, for other disease conditions and insect pest conditions will make a big difference. So always try to keep that rotation in your field. And I'm talking about real rotation with broadleaves, not barley wheat rotation, which sometimes is growers they tend to do that, and we need to try to avoid as much as possible. Tillage will certainly help to keep the numbers down. Again, no-till is predominant in a lot of our dryland conditions, most of or all of our dryland and rain-fed areas, so it may not be a possibility. But trap strips is something that has been used by some producers, and they suggest that it will work. So I put a little photo there. So basically, you keep the outer edge bare, and then you have a strip of crop in the middle, and then the next few feet, maybe 20 feet or something, no planting. So that little strip there would help to attract those grasshoppers. And then you could just go in there and have some targeted control, either crush that or just spray it. And that way, still it would be you're integrating the cultural approach with the chemical approach, reducing the cost of chemical applications, and of course the risks that are going to be associated with that. Not just for this pest and other conditions. You don't want to spray something broad spectrum in your field for grasshoppers, and then you have an outbreak of something else because you got rid of the natural enemy. So these are things that you always need to keep in mind, and we try to promote as well. Insecticides are recommended when you have only large populations, more than 7 in 10 square foot within a field, more than 12 when outer edges of the field in 10 square foot. Actually, I just want to change these. 10 square foot is close enough, but you want to. We are basically talking about 3 square yards. So, how we can come up with these? It's kind of it's a practice that you need to do a few times to be comfortable with it, how to monitor. So what you can do is just to look from distance, focus on 1 square foot, and keep an eye on 1 square foot around that square foot. So you would have 9 square feet in that area that you're monitoring. So keeping your eye on the central square foot, you can just gradually approach that area. That would help you to see better, and then you would also see better, and then you would also see these grasshoppers start hopping away. You can count those, and that would help you to give an easier estimate. If you do that a few times, you can do it. So do as many spots in the field as possible. Usually try to pick distant spots, for example, 50 feet apart, 60 feet apart, 100 feet apart, so you get a better idea of what the situation is throughout the whole field. As I said, we expect them to be more concentrated on the field edges. Management with insecticides, we also, as I said, there is larger scale management. With the years that we had outbreaks, they have those, and they're also integrated. What they usually do, they don't spray whole rangeland. They spray strips. So they just go spray 1 strip and then leave some parts unsprayed, and then spray another one. So basically alternate between those strips that they spray if it's air spray. And that way you have other organisms to move into these areas that are not, they would enable them to move and be protected. And at the same time, you can cover a way larger area with the same amount of insecticides that you're applying. And of course, the cost would be much less. And it has been effective. They tried that in Montana. I was looking at these articles. They tried that in Wyoming. This approach has been real effective in years that we had outbreak. And of course, we have baits that are being spread throughout. And these baits, they're usually carbamates that is applied. If you have rain, wet weather, those baits could go bad quicker. So sometimes they need to be reapplied as well. So they may not last as much in the environment. So these are things that we just need to keep in mind in order to make sure we do everything we can to protect our crops. Insecticide recommendations, they of course differ from each state, and every year we go and update the insect management handbook for the Pacific Northwest. And you're probably familiar with this, but regardless, I added a QR code here so you can just go there. And it's not just for grasshoppers. You can, any crop that you have problems with, you would have a list of insecticides that are made available that you could choose from. Those includes organic or OMRI certified chemicals for those who do, or applications for those who do organic, and also for conventional production. There's a whole range of insecticides that are recommended. But again, make sure you do consultation before you make those applications. Make sure that you follow instructions on those labels for safety. Take them seriously, and make sure you actually have that threshold that you need to spray. It's not just environmental recommendations. It would save you costs of insecticide application by far, especially for these kind of pests that are usually patchy and we can just control them by a more targeted and integrated approach. Grasshopper program through Idaho State Department of Ag, you need to go to their invasive species webpage. Again, I put a QR code there. They are able to help in some cases. They receive your reports. They can look into it and provide you with additional information if you need to. And of course, we are here to help if it is needed at any point. I think this was my last presentation. So I just wanted to thank some of the funding sources that we have. Especially, I'm going to thank Idaho producers for their support. A lot of the work that we do is through your checkoff dollars that you provide to Idaho Wheat Commission, Idaho Barley Commission, and all those funds go through the research that we are doing. I didn't talk about research here today, but I'm going to be talking about some of those at the different crop schools that we have across the state. So if you're attending those, you would hear more about them as well. So with that, I just going to pass the microphone to Casey, and we can start the discussion.
That's great. Thank you so much. This was a great presentation, and I am very saddened that I got all through middle school and did not know about the telescopic abdomen. So I was very happy that you had that included in your presentation. That was very cool. So I would love to open up the forum now for questions. Everybody's microphone is able to be turned on. So go ahead and ask questions if you have them. And if everybody's asking it, go ahead, Matthew.
You mentioned that grasshoppers are sporadic. Do you expect to see outbreaks become more prevalent in the future?
That is what is mostly suggested. Of course, we can't have a definitive yes, but the direction that we have been going is, especially what I'm seeing in the past few years, and with the continuation in drought, in these dry episodes that we are seeing. So I would say we should be more aware of this problem and keep our eye out there. There is no reason to panic. We just address them as they come. But as I said, these predictive models that we have, no model is perfect, but we know factors, at least a lot of factors that could influence their life cycle and support their populations. And based on those, these predictive models are developed for a lot of the pests. Unfortunately, we know those, but we still haven't put together to be able to put us in a position to make predictions. But for this pest, for grasshoppers, luckily we have that is being done, and we have a grasshopper team that they have decades of experience addressing these. And actually, one of these concerns is that they are a generation that a lot of them are about to retire. So they're concerned about educating the next generation to take over these kind of programs and addressing these complex systems and pests that could be widespread outbreak, could cause widespread outbreaks. And I was reading these papers, and they were suggesting at least 5 years of overlap is needed. So all this experience is being transferred into the next generation of these people that are addressing grasshopper and katydid outbreaks, and that's the direction. So we're lucky to have this predictive system, but if you ask me with the direction that we are going, we just need to be more aware of factors that could influence their outbreak and just address them as they come. At least know what our resources are. So that's one of the things that I try to put in this talk, that it's not that there's nothing out there about grasshoppers. We have a lot of resources. We have predictive models that we could go at least to see, if in my area, how worried should I be? And then simple thing for all of us, just to keep an eye out and go and see what the numbers look like. So grasshopper is something that you go out in your field, you see all the time, they hop around, but it doesn't mean that they're damaging. So we don't want to, worry about their presence. Just count them and look at the damage that they're causing, look at the stage of the crop. And these are, again, these resources that I provided would help you to determine the need for it. So hopefully I answered your question. I couldn't say yes 100%, but I'm saying the pattern indicates that we have to be we have to keep our eyes out for this pest.
Thank you.
Arash, can you hear me? I'm trying to do this from a telephone. I'm not sure if it's working.
Yes, I can hear you.
Okay. Can you talk for a minute about spraying adult grasshoppers and using pyrethroids versus organophosphates? And with the stopping of production of lorfan, do we have any other organophosphates that are still going to be available in the future? And I've typically been mixing the two because I've been told pyrethroids have a little bit more residual and the organos kind of knock them down fast. Is that correct? Or explain that to me.
So, I didn't really look into the list of insecticides for grasshoppers, but I provided that link for the Pacific Northwest Handbook that they have a list of insecticides there. Of course, lorazepam is not going to be on the list. Any chemical that had chlorpyrifos is not going to be on that list anymore. But still, the pyrethroids, they are, I'm very hesitant to recommend pyrethroids, not just for this, for any pest, because of they're a broad spectrum. They kill everything pretty much that comes into contact with. So we want to use that as a last resort. But since you asked, I think I saw Mustang Max is on the list when it comes to pyrethroids. These are, of course, contact insecticides, and they would knock down the populations real quick. And of course, they would knock down the natural enemy populations real quick too. So keep that in mind. And as I said, count before you apply those insecticides and make sure they're damaging. We see a lot of them as we walk through fields. I walked through a lot of fields, but there was, out of probably 50 fields that I visited last year, I had only 1 or 2 that I would say, yes, the numbers are at the rate that you probably need to do something, at least a spotted control. But I know there are places that were heavily damaged too. So, yeah.
My experience, if you can still hear me, is it's in oilseed crops that the damage is severe. In flax and mustard and canola.
Yeah.
They'll just strip those seeds right out of the pods so fast.
Yeah.
So yeah, it's just. But yeah, I'm getting recommendations from my local chemical guys, like a full rate of Mustang Max and a quarter rate of organophosphate, like a Warrior or something. And I just nobody can seem to get on the same page whether that's right or not.
Warrior is a pyrethroid, but the thing is, if you have adults, go with the full rate. If at nymphala stage, you may be able to get away with not full rate, but again, most of the damage that we are seeing is with the adult, or I've seen or heard about has been with adults. And for adults, I personally wouldn't recommend lower dosage. Whatever maximum recommended dose is probably what you want to go with for grasshoppers.
Okay.
Yeah, I think. Oh, okay. We still have you. All right. So yeah, for yeah. But again, check that handbook, because there are a lot of chemicals that are recommended, and you could choose from that list. And if you email me, I can actually send you the link if you don't have that link.
Okay, but no truth then to the residual part of pyrethroids, or is that like you're worried with grasshoppers? You can kill the ones in the field, but it's the ones in the neighbor's field that'll be there the next day that you try to avoid. But is there anything that way?
Yeah, the residual effect is something that again has been brought up. You want to use for grasshoppers, if you have an outbreak, you want to have some extended protection. So using chemicals that have high residual would be recommended. But again, when it comes to insecticides, I'm very hesitant to, because it's impacting natural enemy populations. So there is just this trade-off that you need to consider. Do you actually need to use insecticides? But yes, if you apply something that is going to be there only for a few days and then you have to reapply, that would be a problem. So apply something that at least provides you with a couple of weeks of protection. That would be that's what I would do personally in my field. But again, keep in mind that there are conditions that, if you spray and you get bad weather, it doesn't mean that your spray is going to be effective. And I remember seeing some recommendations there in cases that you need to go and redo the application. I can dig those up and provide that documentation to you, but I just don't remember on top of my head all those details.
Okay, well, thanks.
You're welcome.
Hey, Arash, it's Jared Spackman.
Hi, Jared.
Quick question. What are the natural predators besides like birds and things? Like, what are the other insect predators for grasshoppers?
Grasshoppers. So they eat each other, for example. But yeah, that's a good question. Birds are one of the main predators. We have some generalist predators that would feed on them. There are some large wasps that could feed on them. Predatory beetles, especially when these are at the nymphala stage, they're out there in the field to feed on them. There's not much work done on parasitic wasps, but there are wasp parasitoids that will lay eggs in grasshoppers too. So they are, as I said, there are a lot of entomopathogenic organisms that are out there that will infect grasshoppers. Bavaria bassiana is one that is registered and is available in the U.S. and you can apply. But there is another species of Bavaria, acari or something like that, that is used in Australia. We don't have it here in the U.S. We haven't been able to find it in the U.S. yet, but that appeared to be very effective natural enemy against grasshoppers too. But yes, grasshoppers, when you have large populations, they feed on one another, and perhaps that would actually keep them in line when they're moving. So if they actually go the wrong direction, they're going to be food for another grasshopper or katydid. When it comes to Mormon crickets, for example, it's a very common behavior that they have. So yeah, and the predator changes as they increase in their size. So the smaller they are, they could be handled by a lot of those common generalist predators. As they get bigger, the range of predators that could feed on them becomes smaller and smaller.
Cool, thank you.
They actually have some interesting mechanisms as they become adults to protect themselves from predators. You know, they're pretty strong in kicking off predators. A lot of these species of grasshoppers, they have bright coloration in their wings that they use to scare predators, or they actually use it as a mechanism to hide. So, you know, when they take off, these predators are following them. They look for those color patterns on their wing, and then they land. So they just match their background, and the predators is still having the search image of that color spot, and they try to find the grasshopper, but now the grasshopper is matching the background so they can get away from predatory birds, which appear to be one of their main predators for the adults of the adult stage. They have this death feigning behavior as well. Some species of grasshoppers, they just become stiff and they don't move, and the birds can't even eat them like that. So, and there's nice videos of frogs and birds trying to eat grasshoppers on YouTube if you look it up. So, yeah, they also evolved to defend themselves against those predators as well.
Okay, are there any other questions? Not seeing any, so I think we will thank Arash for his time today and great information. We really appreciate the detail that you went into and taking time to answer all the questions. I think that this is a great format where we can have a little bit more of a conversation on these topics. And want to just encourage everybody who participated today live to please fill out the evaluation that you will receive. And anybody who had registered and is watching this delayed, you will also receive that. So even if it's later, please fill out that evaluation so that we can make these even more useful for growers and also recommend new topics for future webinars. So thank you everybody for your time. Arash, thank you, and appreciate everybody's time. Have a great afternoon, everybody.
Thank you, and it was good to see you all.
Bye-bye.